So in this video, we're going to learn multiplication of matrices. Before that, let's look at the do now for today. So here the question is, which of the following has no solution? So let's look at the problem. So option A is a subtraction problem. And we know for subtraction problem, each element in each of the matrices has to have its corresponding element in the other one, right? So for the option A, 5 is corresponding to 2, -6 is corresponding to -4, 3 is corresponding to 0. Second row, you have the 3 corresponding elements in the second matrix. The third row is the same. So for the first option, we have a solution. And for option C, matrix A plus matrix B. So for the addition problem again, each element in the first matrix has to have a corresponding element in the second matrix. So 5 add 2, 2 add 3, second row 0, 4, 1, 1, last row. Each element have the corresponding element to add up. So for option C, you have a solution. Option D, you'll have a number multiplying the matrix. So you just need to distribute the number to every element inside of the matrix. So for this problem, we can do it, right? And for the option B, can we solve it? So you have two matrices subtracting each other. So for subtraction, each element in the first matrix has to have a corresponding element in the second matrix to subtract with, right? So first row, first element 3, subtract 6, -1, subtract 2. However, you have a 2 in the first row, third column that has no corresponding number here to subtract with. So for option B, you cannot calculate it. So option B has no solution. Okay. And today we're doing multiplication, but today's multiplication is different from what we learned last week, which is scalar multiplication, which means you have a number outside of a matrix. And to multiply the number outside, you just need to do the distribution. And each arrow is a multiplication here. Okay, so this is the scalar multiplication. And today we're going to do multiplication of two matrices. So what are we going to do? So here you see what? You have first matrix multiply the second matrix, right? And let's look at the special things about the two matrices. The dimension or the name of the first matrix is 2 rows, 3 columns. So it's a 2 by 3 matrix. The second matrix is 3 rows, 2 columns. So it is a 3 by 2 matrix. Okay, so when you decide whether you can multiply the two matrices or not, you look at the column in the first matrix and the row in the second matrix, and they must be the same. Okay, one more time. The column in the first matrix must be the same as the row in the second matrix. If you meet this requirement, it means you can multiply the two matrices. Otherwise, you cannot multiply them. There is no solution. Look at one more problem. Then we're going to come back. Okay? So here you have two matrices multiply each other. So first check it to see if you can work on this problem. Okay? How are you going to check it? Write down the dimension of each of the matrix. So first matrix is 2 row, 3 columns, so it's 2 by 3. Second matrix is 3 row, 2 column, so it's 3 by 2. Okay, and you see the first column and the second row equals each other. It means you can keep working on this problem. So how are you going to do the multiplication? Okay. First, you're going to use first row, everybody inside, times first column, everybody inside. Okay. So negative 3 times negative 8. First guy times first guy, second guy times second guy, last guy times last guy. Okay. So negative 3 times negative 8, 2 times 1, 5 times 0, and add up the 3 multiplications, you have 26. Where do you put the 26? Okay, so this is first row, first column. So your answer is also in the first row, first column, this place. Okay, and we haven't finished using the first row in the first matrix. So what are you going to do next? You're going to use first row again, multiply second column in the second matrix. Okay, and again, first guy times first guy, last guy times last guy. Okay, so negative 3 times 2, 2 times 5, 5 times negative 3. Add up the 3 multiplications, you have negative 11. Where do you put negative 11 in your answer part? So this is first row, second column. So your answer is in the first row, second column here. Okay, so we finish up using the first row in the first matrix because you don't have any more column in the second matrix to multiply with. Okay, so we finish doing the first row. Okay, now let's do the second row. Again, you're going to use the second row in the first matrix, multiply each of the column in the second matrix. So let's use the second row, multiply the first column, 7 times negative 8, 1 times 1, 0 times 0. And add up the 3 multiplications, you have negative 55. Where do you put it? So look at your original column and rows. So this is second row, first column. So your answer is in the second row, first column. Okay. Last one. Second row, multiply second column in the second matrix. Okay. So 7 times 2, 1 times 5, 0 times negative 3. Add up them, you're going to have 19. So 19 is the second row, second column in your answer. Second row, second column is here. So you're finished doing the multiplication of the two matrices. Okay? So one more time, first row times each column in the second matrix. Second row times each column in the second matrix. And that's it. Okay, and now let's go back to see this problem. So for this problem, can we solve it, right? So here you have two matrices times each other, okay? And let's write the name down. The first matrix is a 2 row, 3 column, so it's 2 by 3. The second matrix is 2 row, 2 column, so it's 2 by 2. And look at the first row and the first column and the second row, and you see the two numbers are not the same, so I know that you cannot solve it. However, why can't we solve it? It is because, let's take the first row. If we can solve it, we're going to use the first row times the first column, right? So first guy times first guy, second guy times second guy. However, you have a last guy here, but you don't have anything you can multiply here in the column. So you have one element that you cannot multiply with. So for this problem, you cannot solve it. That is y. Okay. So now let's do some practice. So which one of the following cannot be multiplied? So let's write their name down and look at the column and the rows, right? So the first one is 1 by 3 matrix times 3 by 2 matrix, and we see the first column and the second row equals each other. So you can solve it. The same thing, 2 by 4 times 4 by 3. The two numbers are the same, so you can solve it. Last one, 3 by 2 and 2 by 3. The two numbers equals each other, so you can solve it. Last one, option C, is 2 by 4 and 3 by 4. The first column and the second row, they don't equals each other, so you cannot solve it. Okay? And the y, one more time. If you solve it, you're going to use the first row times everybody in the first column, right? So 1 times 1, 4 times 2, 6 times 9, 10 times what? You don't have one more number here, so you cannot solve it. That is the reason. Okay. Next one. Multiply matrix A and B. So first check it. Can you multiply them? So this is 1 by 3. This is 3 by 2. So the two numbers inside equals each other, so you can work on it. So keep working on it. Okay? So use the first row times the first column. 1 times 2, 4 times 5, 6 times 7. Add up them, you have 64. And then you have a second column, so keep doing it. Use the, okay. So you have 64, right? Where do you put the 64? Is first column, first row. So first column, first row is here. Okay? And then first row times second column. 1 times 3, 4 times 8, 6 times 9. Add up 89. Where do you put 89? Is first row, second column. So first row, second column is here. So C is right. Yeah. Next, multiplication. So check it. 3 by 2, 2 by 3. The numbers inside are the same, so you can work on it. So work on it. Right. First row times first column, then second column, then third column. So let's do each of the column one by one. So 8 times 7, 5 times -1, add up is 51. Where do you put 51? First row, first column. So first row, first column, 51. Okay? And then first row times second column. 8 times -8, 5 times 3, add up -49. And where do you put it? First row, second column. So first row, second column is here. Okay. Next, first row times third column. 8 times -6, 5 times 2, add up -38. Where do you put it? First row, third column. So first row, third column is here. Okay. So by looking at the first the first row in the answers, you know option A is right. Okay. If you wanna keep trying it, you can. Next, we're gonna use second row times first column, second column, last column. And then we're going to use last row times first column, second column, last column. I'm not going to do it, but if you're interested, you can check to see if the rest of the elements in the answer are right. Next question, multiplication. So this is 2 by 3. This is 3 by 2. Numbers inside are the same, so you can work on it and do the multiplication. So first row times first column, then times second column, right? 1 times 7, 2 times 9, 3 times 11, add up 58. So first row, first column is 58. Which one is right? 58. Maybe this is right. This is wrong, right? And then first row, second column, 1 times 8, 2 times 10, 3 times 12, add up 64. So it's first row, second column, first row, second column, 64, 64. Okay, so A and B, you still cannot cancel one. So let's keep calculate. So you finish using first row to times each of the column in the second matrix, right? And now we're going to use the second row times first column, then second column, right? 4 times 7, 28, plus 5 times 9, 45, plus 6 times 11, 66. Add up the three numbers, we have 60, 73, 139. Okay, so where do you put it? Second row, first column. So second row, first column. This is not 139. Second row, first column. 139. So this must be right. Let's check the last column, the last element. So second row times second column, right? 4 times 8, 32, plus 5 times 0, 0, plus 6 times 12, 72, add up is, I'm sorry, this is 10, not 0, right? 5 times 10 is 50. Add up, you have 82. 154. Which is a second row, second column, second row, second column is here. So B is right. Okay. Next one. First row, first column. 1 times 7, 2 times 9, 3 times 11, add up 58. First row, first column. So first row, first column, 58. Okay. First row, second column. Oh, we just did this question, right? This is the same as the last one we just did, okay? So I know the answer is B, right? I'm gonna skip this one. And there's no more questions. And that's it for multiplication of two matrices. First, you're gonna check if you can multiply the two matrices by write the dimension of each of the matrix down and see if the numbers inside equals each other. If they do, you can keep working. If they're not, there's no solution. Okay? And then when you do the multiplication, first row multiply each of the column in the second matrix. Second row multiply each of the column in the second matrix. If you have more rows, next row multiply each of the column in the next matrix, and that's it. Okay.